Okay, trigonometry. This time we're going to find a side of a right-angled triangle. Now let's do that using some examples. So I'm going to show you all the questions. So I'm going to push this one up a bit. Okay, example 1. A rhombus has one diagonal 12 centimeters long and the other diagonal makes an angle 28 degrees and 23 minutes with the side of the rhombus. Okay, now rhombus is a tilted square, so all four sides will be equal. So I'm just going to call them X as my side, and that's part A. Part B, we have to find the length of the other diagonal. Now I'm just going to call this diagonal, and the half of that is Y, the other half is Y. So diagonal of the other diagonal will be 2Y, because it'll be Y plus Y. Okay, so let's do part A. Now before we do part A, I'm just going to look at I have to find the right angle here, right angle triangle. So this is the only angle we got, so I'm just going to look at this. Okay, this triangle right there. So that's a right angle here, because this is a straight line. Okay, so if I do that, I will have this part will be 6, and that's 6. So it's a half of 12, so I'm going to write 6 and 6 here. So if I look at the triangle, this triangle, see if I can color it in so we can concentrate on just particular. Yep, so we are looking at this triangle right there, and I have to find X. So to do that, I think I need to look at, this is my hypotenuse, that's my opposite. Okay, so what will give us which trig ratio? So I'm going to write SOHCAHTOA. So one that has O and H that we have to use. We can't use this one because we don't know what this is. So O and H, I'm going to use sine. That's why I picked sine here. So I'm going to use sine 28 degrees and 23 minutes equals opposite over hypotenuse. Opposite over hypotenuse. That would be 6 over x. So always good to actually write it down and label the right angle triangle so you know which trig ratio you need to use. So what I've done is I'm just swapping this, and x comes as the subject, and then it'll be equal to 6 over sine 28 degrees and 23 minutes, and it'll be 12.6 to the 2 decimal place. Okay, and then to find the y now, because that was the other diagonal we have to find, so we're still going to use this triangle, and this one is adjacent, isn't it? Because it's got 2 angles on the side, so it's adjacent. So I'm going to use, let's see, since I can use O and A, so which one has O and A? Yep, tan. So tan 28 degrees and 23 minutes equals opposite over adjacent. Remember, opposite was 6, adjacent is y. Okay, and if we do the calculation, you'll get 11.104487 dot dot dot, but the other diagonal is 2 times y, or y plus y if you want. It's a double, so the answer should be 22.2. Okay, so that was a second example. Let's have a look at the second example. Okay, this time we're using a kite. So let's have a look. Let's see if I can show you the whole thing roughly. Okay, example 2, kite ABCD has diagonal BD equals 15.8. So BD is 15.8 centimeters as shown. And if angle ABD, that's a 57 degrees and 29 minutes, and DBC, on the bottom here is a C, and the angle is 72 degrees and 51 minutes. Find the length of the other diagonal AC, because this was 15.8, and so this one is what we have to find, AC. Okay, let's have a look. So I'm going to let AO, oh, hang on a minute, I'm just going to call this one as O, the middle intersection part. Okay, so AO equals X, so I'm going to call this one X, and the OC as a Y. I'm going to circle this so I can see them better. Okay, and AC obviously will be the sum of the X and Y. All right, so that's what we have to find. In triangle ABO, let's have a look. ABO, this one. We're looking at this one. So I'm just going to highlight this. So just remember that. So I'll just sketch this again. So we need to find the X. What's this one? X is opposite, and one that with two angles would be adjacent. Okay, so with the SOHCAHTOA, after you label them, we got O and A, isn't it? Which one has O and A? Tangent. So I'm going to go 10, 57 degrees and 29 minutes equals opposite over adjacent. Opposite over adjacent. X over 7.9. X will be just timesing it together. That'll be 12. Okay, X is 12 centimeters. And we're looking for now Y. Okay, because to find the AC, you need to add the X and Y. So we haven't really quite finished the question yet. We're halfway there. So I'm looking at the other half triangle, and I'll just re-sketch this again. And let's see, that's my, I'm just going to label them. That's my opposite. And that's my adjacent. So opposite and adjacent will also, it'll be 10. So it'll be 10, 72 degrees and 51 minutes equals opposite over adjacent. And you will get this centimeters. And therefore, your AC is X plus Y, which is 12 centimeters plus 25.6. That's 37.6. And that's to the nearest centimeter, it'll be 38. Okay, so let's have a look at the next one. So next example is for the finding an angle this time in a right angled triangle. Now when you're trying to find angle, you need to use in a calculator shift and with 3 trig ratios. Could be sine, cos, tan. Okay, to find angle. All right, first example. Okay, rectangle ABCD has a line BE drawn so that angle AEB equals 90 degrees and the DE equals 1 centimeters. The width of the rectangle is 5 centimeters. I've actually sketched the diagram below the question. So, and then find angle BEC. BEC, that's the one I have to find. I'm going to call it theta. And then find the length of the rectangle, which will be this. Okay, I'm going to call it X. Okay, so let's have a look. X. So first one, we have to find angle BEC. I'm going to call it theta, and the other one is alpha. Okay, so if you look at the sort of bigger picture here, to find this theta, that's a straight line, so it'll be 180 take away, that's 90 degrees, and take away the alpha will give us theta. Okay, that's what we have to do. So we need to find alpha, so I'm going to use this triangle, isn't it? This one. So I'm going to color that in. We're looking at this triangle right now, and of course the side is a rectangle, so it'll be the same, 5 centimeters. Okay, and that's 1. So to find that, we're going to use tan alpha, because what's this one? That's opposite, and that's adjacent. That's a TOR. So it's a tan equals opposite over adjacent, 5 over 1, which is just 5, and alpha will be 78 degrees and 41. Okay, and therefore the theta, which is angle BEC, will be 180 take away 90 take away alpha, and it'll be 11 degrees and 19 minutes. Okay, next one, part B. We haven't quite finished the question yet. So part B of the question 2, we are going to look at. We need to find the length of the rectangle, which I called it X. So to find the X, let's see if I can bring the diagram again. To find X, that's the same as AB is the same as CD. So if I can find EC, I can add the 1 of the DE. I can find the length of AB. Well, DC is another length anyway. So to do that, I have to do DE plus EC, because DE was 1, and then EC we have to find. So to find the EC, I'm using triangle BEC. So I'm using BEC, which is the other big triangle. So I'm going to put this in there. This triangle we're going to look for, and I have to find this. Okay, so let's see if I can find, because we found a theta, which was 11 degrees and 19 minutes, and that's my opposite, that's my adjacent. So A and O, it'll be tangent. Okay, so TOR, opposite over adjacent, which was EC, and I'm going to call EC as X, and can find 24.98, and which is roughly 25 centimeters. So that's my length of the rectangle. Okay, but that's not really our answer, because that's just finding, I shouldn't call X actually, D, E, C. So the length will be DC, isn't it? DC is what? DE plus EC. DE was 1 plus EC is what? 25. So it'll be roughly 26 centimeters. That's my length. So EC, I'm not going to call EC X, because that was my length. Okay, good. Now example 2. Well, that's quite a long question here. Frankie is standing at the side of a road at point A, and it's 15.9 meters away from an intersection. she is at an angle of 39 degrees from point B on the other side of the road. And there's 2 questions, but don't panic. Diagram is given. Yes, fantastic. So this is the situation here. Okay, now there's 2 questions. Part A, what is the width, which is W here, of the road? And then part B is a Frankie walks 7.5 meters to the point C. At what angle is she from point B? So theta we have to find. So Frankie is here. Okay, so let's have a look how we're going to solve this. So I sketch this diagram again, so we don't have to keep looking back. So that's what it is. I've just put that in because I know we need to use it for part B. But anyway, so we have to find width, W. So I can use this whole triangle here. Okay, this whole triangle is 39 and that's 15.9. That's the question mark we need to. That's opposite, adjacent. Opposite and adjacent is tan, isn't it? So I'll sketch this again. I'll get tan 39 degrees equals opposite over adjacent, and I'll get 12.9. Okay, not a problem. Part B is the one that we have to find the angle, isn't it? Yep. So let's have a look. That's what we need to find, that 8.5 up there. So this is the angle we have to find. So 8.5, and we know W, 12.9. So I'm going to sketch this diagram here again. It's just easier for us. So 8.5, right angle triangle. That's something we need to know. So that's opposite and that's adjacent. So it's a TOR, so it's 10. So tan theta equals opposite over adjacent, but opposite is what? 12.9 from the part A, and then 12.9 over 8.5, theta equals, now remember, to find the angle you have to use shift 10. So when you do shift 10, you'll get the 10 inverse. It'll be 12.9 over 8.5, and you'll get the answer. If you don't remember, I'm just going to do this calculation for you. So we do shift 10, and what was it? 12.9, but use 12.9 over 8.5, close it and press that. So it'll be 56 degrees and 37 minutes because the second is less than 30. Okay.